Metasurfaces are important because they can manipulate the electromagnetic waves for a wide variety of applications. This video is related to our novel nanofabrication method to fabricate multi-part unit cell metasurfaces based on two sequential exposure by laser interference lithography system that we have in our clinic.
Here I'm showing the schematic of the conventional two-part grating structure which has one ridge and one groove in one periodicity, and here I'm showing the four-part grating structures that we are going to fabricate in our lab based on our laser interference lithography method. There is no doubt that increasing unit cell complexity, we will get wider design space and improve functionality of the periodic meta structures. Until now, most fabricated four-part fill factor devices have employed E-beam lithography method, but this method is time-consuming, it's expensive, and is impractical to pattern, especially when patterning on the large surface areas is needed. Here I'm showing the schematic of different steps of our fabrication of our proposed fabrication method. The first step will be first exposure with periodicity of lambda 1 and exposure time of T1 on a photoresist coated SOQ wafer. Second exposure will with periodicity of lambda 2 and exposure time of T2, where the second periodicity lambda 2 is exactly equal to the half of the first periodicity. After that, developing of the exposed photoresist, we will end up with four-part grating pattern on photoresist, which this pattern can be transferred to the silicon by using reactive ion etching process or RIE process. Here I'm showing the schematic and the scanning electron microscope and atomic force microscope images of the fabricated device that we used our method to fabricate these four-part grating design in one-dimensional and two-dimensional structures. The method of two exposure not only can be used to fabricate four-part periodicities, but also to fabricate multi-part unit cell metasurfaces as well. It happens when the second exposure and the second periodicity is not equal to half of the first exposure period. At this case, the final period is set by the least common multiple of two periodicities at work. Here I'm showing the schematic of the fabricated 10-part fill factor design and the scanning electron microscope of the fabricated device based on the method I just explained. At the end, I want to acknowledge the funding sources and my colleagues in Nanophotonic Device Group, especially my advisor, Professor Robert Magnuson. Thank you.